I know that docs are not always the most glamorous or exciting thing, but hopefully the word GraphQL got a few of you in here. So today I'm going to be talking about how we rebuilt our GraphQL documentation as well as our liquid docs at Shopify. I run a team called Learn out of Toronto, Canada, for Shopify. I'm also the proud owner of an adorable little puppy named Walnut. You can follow him on Instagram. He has more followers than me. I actually started out at Shopify as a front-end developer about 6 years ago. But now I'm a user experience manager. I worked in DevRel for a few years, teaching and speaking and talking with developers on how to build on Shopify as a platform. The team that I work on now essentially focuses on building better developer experiences for folks who are building apps or themes, headless solutions, and that use our APIs and the rest of our developer documentation, as well as our tooling. If you haven't heard of Shopify before, Shopify is a commerce company. We essentially allow merchants to set up online storefronts as well as we have POS systems for brick and mortar stores. And currently there's over 2 million merchants that use Shopify in 175 different countries. But one of the main properties that my team owns is the developer docs for all of Shopify. So any developer, anytime you're building on Shopify, you're using something that my team owns. And a couple years ago, when we first formed the team, the developer docs were in a pretty bad state. Like any company, our developer docs have been built up over time by a lot of different teams, which means that we have our own share of problems when it comes to different iterations of components and content over time, different teams publishing content. There's inconsistency across how some of our APIs are actually documented, and in some cases, just like a lack of curation that was explicit when thinking about developer journeys and paths for building. And so there's lots of different ways of organizing a documentation site. This is our old documentation. It was pretty void of any kind of personality. And really the site itself, this is sort of what it looked like after we did a major migration. A lot of the content for the developer documentation originally existed on the same site as all of our merchant documentation, which is like anything to do with like creating a product for the first time to like how to save a draft order or something like that. And so we did a big migration project, and we reorganized the IA into essentially different content types, but rather than a goal or use case. But it made sense at the time to do this because of the constraints of the migration and limitations when it came to curating content. But as you can imagine, there was a lot of context switching for folks. Somebody who's developing a particular thing, let's say an app, might have some documentation open, let's say like a page about a specific concept, as well as a tutorial, and then also the API documentation. So we were watching people basically use things in like 3 different windows and sort of switching back and forth. And so we decided when we did the redesign to really think about like what are the different use cases that people are actually building for, and curating our IA as well as our content around those use cases. So with the redesign, we rebuilt the information architecture just to make things easier for developers, taking user journeys into account. The primary navigation is organized around developer goals. That is the thing that developers are building, whether it's apps or themes, and we're emphasizing action and helping developers get started as quickly as possible. Once a developer is within the app's navigation, they can see an end-to-end journey or workflow about building an app from getting started to deployment. And like chapters of a book, all the more conceptual information is mixed in with tutorials so that you can actually follow like a story. It makes a more obvious path for folks who are reading our documentation and allows them an easier way of sort of parsing things. So I'm going to get into sort of like the bits and bobs behind the scenes, because I think that's what people are interested in. So we rebuilt a design system from scratch. Previously, the site was using our marketing design system, which was a lot of really big fonts, a lot of a very small color palette specifically for marketing products. But we realized that that wasn't the best thing to use for documentation. So our first step was coming up with a brand new set of design tokens and rebuilding essentially the foundations of everything. This included color tokens for major themes, like docs or our different APIs. So if you actually travel across our different API references, you'll see like a different sort of theme, because one thing that we noticed was people were actually like sometimes not realizing which API reference they were in, because we have an API called the admin API, which is how most developers interact with our Shopify admin, but it comes in both GraphQL and REST. And people were getting confused sometimes as to which version of the API that they were looking at. And then we also have minor themes for things like types of messages, notes, warnings, and so forth. So we made sure to define all of these application tokens, all of these themes and their tokens for components, as well as provide guidance as to like how to actually use them and how they would get applied to different components. We chose font families that best serve developers, so thinking about fonts that were more readable at smaller sizes, specifically like typography pairings that that have the monospace font the same X height as copy, so that when you're reading through the line of that text and you have interspersed code, it reads a lot easier and you don't have like your eye jumping around as much. We're using a font called JetBrains. It's an open source font, if any of you are curious, if you're looking for a nice monospace font. It also has really great glyphs. And you'll see those glyphs actually used in our GraphQL documentation as iconography later on. We define things like cards and surfaces with elevation guidelines based off of depth tokens for development use. And we added elements of storytelling with illustration, along with guidelines on usage and how to scale those things. In terms of how we built out our components, we're using Storybook behind the scenes for our internal developers who reference those, as well as for anybody who's wanting to use and build new pages. And so if you haven't, how many people are familiar with Storybook? Probably use it? Great. If you haven't, it's an open source tool for building UI components and pages in isolation. It streamlines UI development and testing and documentation. We use it to document all of our components as part of the redesigned experience. All of our components are built in React. But we're going to look at the reference documentation now and what we actually did there, how these things are applied. So we have that base layer now. As you know, REST and GraphQL are different. How many people use REST regularly? How many people use GraphQL regularly? It's about 50-50. This is sort of a similar split when we look at our traffic in terms of our APIs. And so REST and GraphQL are fundamentally different types of APIs, especially when it comes to fetching data. With a REST API, you would typically gather data by accessing multiple endpoints. For each piece of data you retrieve, you'd have to make a separate request to do so. With GraphQL, on the other hand, you simply send a single query to a GraphQL server that includes all the concrete data requirements, and the server responds with a JSON object. So what did that necessarily manifest or mean for our API references? Well, we decided that we should cater to the task at hand and provide the right tooling for the job that you're actually doing. What that meant was creating sandboxed experiences for both GraphQL and REST. So each of those references are have their own sidebar experience. And components are specific to how people actually use the API. So we created different ergonomics for particular use cases in both APIs. This meant that we had some components that were specific to REST that you might only see, or some that you might only see in REST and some that you might only see in GraphQL. But we did this in order to make sure that when you're using the API, it makes sense for the use case and what you're actually building. So REST has been around for a really long time. there are best practices for writing REST references. They're pretty straightforward. So we followed them. We didn't try to reinvent the wheel here. I think like oftentimes when you do a redesign, you see people try to build everything themselves. I think like with a project like this, we know that people have a good reference for how they use REST documentation. And so making sure that we're following those best practices and patterns that we know that work and are useful is really important. So we're taking advantage of the familiarity of CRUD to give developers a comprehensive view of what actions they can take. If you're not familiar with CRUD, it's an acronym that refers to the 4 functions that are necessary to implement a persistent storage application. So create, read, update, and delete. And we saw through prototyping and user testing that developers already used in our old documentation in-page navigation for jumping around. That in-page navigation was in part there because the sidebar really sucked, to be honest. And so over time, people would jump around the page using that in-page navigation. We decided to keep that, but lay things out in a slightly better way and make sure that things were easier to find and spot. And so because we saw that was useful, we decided to make different actions more obvious with different color tokens. So additionally, we gave developers multiple ways of navigating, so they can still use the sidebar. They can use the in-page navigation. Further down the page, we provided the full JSON object for developers so that they could understand how the data is formed and what to expect. And taking advantage of our API libraries that we built out over the last several months, we also built out a new code block component, which basically showcases a bunch of really great examples, all generated from these API libraries in languages like Ruby, Node, and PHP. But the same can't be said for GraphQL. There aren't necessarily really great examples of GraphQL references online. Most people use like editors that already pull the schema directly in for them. So if you're looking for references or if you're looking for GraphQL references online, oftentimes Shopify is sort of deemed as like the #1 or like in the top few. But we actually didn't think that our references were particularly good. And so we thought about how to curate that experience. So when you look at a typical GraphQL reference, it's generally just a giant generated list from the schema. It's not really that helpful. It doesn't really match our mental model of the type of information that we're looking for when we're building. So most GraphQL schemas, this is GitHub's, just spit out things like queries, mutations, objects, and other GraphQL types. But for someone who's new to GraphQL, this might be a bit confusing because things are split. Like say, for example, you want to query a product. Certain actions like mutations are going to be split out from the objects themselves. And that can be meaning that you have to go back and forth between different GraphQL types to do something that is sort of related to one another. And so because our REST documentation was pretty understood by most developers, what we did was we wanted to actually organize our GraphQL documentation by a similar system of what people are actually building, whether that's customers or what kind of data people are looking for, whether that's customers, products, or orders. Intuitively, I might actually want to look for those things. So when we look through our GraphQL documentation now, what we tried to do was deprioritize the things that we didn't actually think were that useful for developers. So certain GraphQL types are just things like inputs or enums. It's not something that people really need to know about, but what are the actions that people are doing most regularly? They're looking to make change to something, so use a mutation, or looking for a particular object and its properties. And so we prioritized those things within categories that made sense to how people sort of mentally mapped what they were trying to do. Essentially, what we're trying to do here is improve developer ergonomics by asking what is contextually useful for a developer at a given time. So if I had to define ergonomics, it's the science of fitting a workplace to the user's needs, right? It aims to increase efficiency and productivity while reducing discomfort. So what we're trying to do is create better experiences through improving the ergonomics for our users. In order to do that, we as Shopify should be taking on the cognitive load and processing the data so that our users, developers who are building things, don't actually have to do that. So what does that look like? Well, we wanted developers to help visualize the schema and help them navigate between different types. So learning which objects are returned by which queries and which queries are returned by which object. We took a bet and we created something that we call GraphQL maps, which are specific to Shopify's GraphQL reference as a wayfinding and learning tool for understanding how GraphQL works. One of the hardest parts about building our new GraphQL documentation is we were building a UI that was intuitive for somebody using the documentation, but that doesn't necessarily match up with how the schema itself is built. And so in order to group things like deprecated fields together or show connections grouped together meaningfully, we need to parse the schema and rebuild it to match the data shapes on the front end. So if we're going to take a look at an example of a GraphQL object type, when you look at a normal GraphQL type, fields are nested at different levels. In this case, we're looking at an object type for an object called app. And deprecated fields and supported fields are intermixed with each other. They're not grouped separately. Finally, connections are mixed with other fields rather than being on their own. And so what we did was build a parser. We would parse the schema as it exists, simplify the GraphQL type before inserting it into a database to be then queried for our reference documentation. We would surface the details and SQL columns for easier querying later on by the front end of our app. So if you look closely, we've simplified the field type definitions so that they contain relevant information at the right level and can be referenced later. We separated out fields from connections and from deprecated fields so we could tackle each of those concerns on their own within the UI. And in order to create a relationship that goes in both directions for those maps, we need to create these GraphQL types with additional information. So if you look at a couple different types here, both of which reference app. One is app query, the other is an app feedback object. However, in our app object, we don't have any reference back to the app query and the app feedback object. So we need to update the database with that additional information. Which then allows us to link all the references in the GraphQL map and create relationships in two directions between different objects. We created different layouts and components for different GraphQL types in the hope of creating the best ergonomics, like I said, for the task at hand, instead of a generic template for all types. So for example, this is a mutation page. It has both a code example as well as a link to a map to understand how a mutation query can modify data and what the return types are. Additionally, we've also showcased different input variables as well as a schema definition so a developer can understand what type of values and input variables take. And inputs are green so you can see them in both the code example as well as in the pros on the left. So we're creating visual connection between different areas of the page. On query pages, we show required fields, a code example, and map to related types. And we showcase key examples for queries in multiple languages, the query itself, curl, Node, and PHP. So if you haven't already noticed, looking at some of the documentation that I've shown, we've included iconography for different GraphQL types in order to make it easier for people to denote what's a query, a mutation, an object, and a connection in those maps. So we highlight queries with indigo and use an opening and closing bracket. We just made these up. This isn't a standard. Maybe it will become one because people will look at our documentation, but we use an opening and closing bracket with a question mark to denote what a query is in the map. We show objects with curly brackets denoted in fuchsia. Again, all of this maps to like the actual colors of those pages as well. And finally, mutations are color-coded in yellow, showcasing that the information is changing. We really tried to have fun by taking inspiration from video games and pixel art. We wanted it to feel like a secret handshake with our developer community. And while the details are subtle and they show sort of different little things here and there, we want to also show that we sort of sweat the details, that essentially cared for documentation means a cared for platform. This summer, we also shipped our new Liquid documentation, which is Shopify's own templating language. How many people have used Liquid in some form? How many people have used Jekyll? To build a Jekyll site, you're using Liquid. It's similar to Twig. It's just a curly bracket templating language. But we carried over patterns from our GraphQL and REST references, like property lists and syntax highlighting, type hierarchy, and so forth. In our Liquid docs, we created a story to help folks learn how to write Liquid. Different people have different learning styles. So in particular, Liquid is a front end, mostly used by front-end devs to really make a store function on Shopify. You can change the templates using Liquid. And so they're more likely going to be visual people or visual learners because they're often doing theming work. And so we have illustrations throughout our documentation tied to a Shopify store that reinforces this narrative of a shop selling different types of potions. So when you look at the examples in our Liquid documentation, it references, even in the content, like different types of potions and things that you're building or changing. So we have these illustrations throughout that sort of are a little nod to open world adventure RPGs. And so you can see here, like in this assign code block, all of the output, when you go to the different types of data, are things that might actually line up with that narrative. We also built interactive sandboxes, which was not an easy thing to do. So developers could actually play in the docs themselves. And these interactive sandboxes actually query a store and pull back information. So we use the Shopify store as a data source instead of stubbing that data somewhere else, because a store, at the end of the day, is tied to our core product. And so when there are updates automatically made or by product teams, that store will automatically inherit those updates. And so it's just a matter of creating more content within that store. And so this way we avoid creating a maintenance burden, but also that store then can basically house all of this really interesting information that creates this narrative. Our Liquid documentation was originally all Markdown files, which presented a problem when it came to content being up to date, because the Markdown files were like stored completely separately from the actual code implementation and how the language was made. And what we had to do, or what we realized through building our GraphQL docs and our REST documentation, is that when you're scaling, it's best to store documentation alongside code. Having those two things close together means that you can write testing, means you can write tests and run a bunch of different things against that repo in order to both generate the documentation, but also make sure and force developers on product teams to write documentation as they're building new endpoints or new things. Currently, internally, we use Yard, and we extended it for different use cases. So Yard is a documentation tool for Ruby. Shopify uses Ruby on Rails generally for most of our stuff, with sometimes like React sort of inside a Ruby on Rails shell. And we use the Yard doc meta tag formatting, which is similar to Python, Java, and some other languages. And it uses an @tag style definition syntax for meta tags. So the way that that shows up is essentially like this. So we extended it for our own use cases. We built and designed and migrated all of the content from Markdown files into what are semantic tags for various metadata. And so that was like not an easy task at all. But we have some really great technical writers that helped with this. And so you can see, for example, a liquid type is not something that by default exists in Yard doc, but we've added that as well as liquid description. And these things match up with semantic stuff for our front end. We also built in a bunch of guardrails for authors because people do things that they're not supposed to. And so we built in testing using build kite for continuous integration, which basically means we have unit tests that run whenever a PR is created. And those unit tests look something like this once you click in. And we have one specifically for the documentation that will yell at you if you don't write it correctly. And so it'll block somebody shipping a PR for a new, whatever it might be, liquid tag, object, what have you, if they haven't also included documentation for that thing. So what are the lessons learned? Keeping things up to date is really hard. It's not an easy task to track down human beings on ever-changing teams. It's not easy to make people care about something that often feels like the last thing on their list once they're building their product or what have you, and they want to get it out the door. Documentation is often thought about at the end of a new feature, not at the beginning, but it should be thought at the beginning because it's really about helping you plan and understand, almost like the technical design of something. And for developers to understand how their code comments then build the documentation is super important. Our admin API is automated to a certain degree out of what we call Shopify core internally. But that's sort of separated from the actual doc site. And so right now, even now, we have a hard time sometimes having people or developers that are new to Shopify visualize or understand how the unit tests that they're creating or the comments they're writing actually end up in the documentation. So if I can give you guys anything to take away from this, if you are building an API or you have a small company still and your API is relatively tiny, I really recommend that you codify ownership of your API endpoints now, because it's a lot harder to do it later when a company scales or there's lots of people owning different parts of the API. So one of the main problems that we have at Shopify is we have hundreds of product teams contributing to our API at a particular or at a given time. It wasn't clear which team owned which endpoints. We only mapped that a year and a half ago. And so what would happen is a team would disband or maybe move to another project, or there would be an org change. And that would leave endpoints with nobody to care for them or own them or make sure that they're up to date. And so we had to spend a lot of time and effort mapping all of our API endpoints to internal teams, codifying their ownership in a tool that's tied actually to our HR and team assignments at Shopify. And so now that we have these operational tools to maintain these ownership structures, when teams change, or there's inevitably a reorg, or people leave Shopify, those endpoints have to transfer from one team to another. And so they're not just left unattended. So this is an internal tool that we have at Shopify. It's like our internal wiki. It tracks both, it has everything from anything that you could look up with regards to building internally, but also we track all projects through it. And it also houses all of our team structures tied to all of our HR tools. And so what you can see here is this is our team page, and we have a bunch of folks. I'm a lead with my engineering manager and then also my product manager. But if this team were to disappear, the ownership of what's codified to this team in our internal tools would then prompt or trigger an error somewhere, and then that would actually force the ownership change. So I'm going to tell you guys a few things that no one tells you. When you improve the ergonomics of the UI, content gaps become more obvious. You probably noticed earlier I had app with the GraphQL map, and there was a giant blank space beside it. great ergonomics don't necessarily mean great content. And so when you improve the UI often of your documentation or any kind of website and require more information to make the end user experience better, what you end up seeing is like more gaps when it comes to the actual content itself. And so if we look at what our GraphQL documentation looked like before we did sort of rewrites and that kind of thing, it was pretty sparse, right? Like this says, represents a media warning for media warning. It's not a super detailed description. And we had, once we did all of the mapping to internal teams, asked teams to then update their endpoints to make sure that the descriptions were actually useful to developers who are building and give you actual information about what to expect. Teams need to own the content quality of their APIs, and you need to build a culture of contribution. There's no way that one team, the docs team or whatever team that is, can own everything. It's just not possible. And so the way that you keep documentation up to date, or the way that you make sure that your references and APIs are up to date, is making sure that everybody feels responsible for those things collectively. The other thing you need to do is document how to write great documentation. If you don't do that, teams don't know what to do. And so they'll do the least that they can. So all in all, we shipped the things. We fixed a bunch more things. And we even got some high praise from the big boss. I say big because, or high praise because he's German, so the word lovely is like him screaming from the mountaintops. But if I leave you guys with anything today, it's to build experiences that help users accomplish their task and then get out of the way. The best design, at the end of the day, is invisible. There might be thought behind the syntax highlighting, iconography, font choices, but all of those things are complementary to content at the end of the day. And all of those things should just work in the background. So think about that when you're building or documenting your next API. We build for people, not computers. And just as generated docs can be great, we have to consider how they're consumed and the audiences that they serve. Thanks so much.